In this video, I will show a numerical example of applying the washer method to rotation around a vertical axis. So suppose we have the two functions, y equals x squared and y equals 2x. They intersect at these 2 points in the first quadrant, the origin and 2, 4, and they make this region between them. Now suppose we're going to rotate this region around the y-axis and we want to use the washer method. Well, first thing we have to do is rewrite both functions in terms of x as a function of y. So y equals x squared, we're going to rewrite that as x equals square root of y. And y equals 2x, that one's particularly easy, we're just going to write that as x equals y over 2. And so when we look now, we see that the curve, the x equals y squared, that's the outer radius. So this is going to be our capital R of y, whereas the straight line, that's going to be the inner radius. That's going to be lowercase r of y. And so the volume is going to be pi times the integral from a to b of the capital R of y squared minus the lowercase r of y squared dy. And here what that is pi times an integral from y equals 0 to y equals 4. From y equals 0 to y equals 4 of r of y squared, well that's just y, minus lowercase r squared, so that is just y squared over 4 dy. Well, this is something very easy to integrate just using the power rule. This, of course, is y squared over 2 minus y cubed over 12, evaluated at 4 and at 0. Plugging in, we get this is pi times 8 minus 16 over 3, that minus 0, and all this simplifies simply to just 8 pi over 3. And that is the volume of the solid rotated around the y-axis. So this is an example of using washer method with a vertical axis. Because we had a vertical axis, we had to change everything to y and perform the integral with the variable of integration equal to y.